So we're going to talk about CI/CD with GitHub Actions. My name is Chris Ayers. I'm a senior customer engineer at Microsoft. I work on the Fast Track for Azure team. So my team is actually part of Azure Engineering under CXP, the Customer Experience Program. We help customers build and deploy stuff onto Azure. And I like to do it through WAF, the well-architected framework. So I help them do stuff reliably, securely, throw in some operational excellence, and you got pipelines and infrastructure as code, and all sorts of fun stuff besides a good architecture. I'm on all the socials, so feel free to reach out. I blog, I tweet, and I have all my samples and everything in GitHub. I like to work in public. Sometimes I do a lot, sometimes I do a little, depending upon how much my day job actually does stuff, because I'm not here supporting Microsoft. I just like talking about cool stuff with people. I'm just a big old nerd. So today we're going to start out with YAML, because you got to love YAML. We'll talk a little bit about CI/CD. I've got some actions, some demos, and then we do have some workshop stuff for you guys to work on, and we'll build some pipelines together. So I want to lay the foundations down, and then we'll start doing some things together that you guys get to build on. And then we'll also talk about deployments and security. We'll touch all the things, okay? So YAML, yet another markup language. Yay! GitHub uses YAML for all of its workflows. YAML is just a superset of JavaScript. I have a little link here. Let me just go to that. So, you guys see this okay? Is that big enough? Can you read that? All right. So you know what? I have a dog. Her name is Zelda. So if I want to have key value pairs, like some sort of key and a value, it's just colon space. You got to have the space, you got to have the colon. And it renders out over into a property in JavaScript. So if I delete it, I'm getting a little bit of warnings. It doesn't really like that. It really likes that space there. I can have multiple properties, like, breed. But see, she's not just one type of dog. She's two. So I can do like lists. So I could be like pit bull and a Labrador. Notice it made a list over there. That's how you do a list in YAML, but you can also do stuff as pure JavaScript because YAML is a superset of JavaScript. So like her favorite things, those might be naps or treats or belly rubs. See, still works. So you can have different syntaxes of stuff. These are all just a list of properties. What if instead we want to make an object? Well, indentation is super important. You got to indent things properly. So everything needs to kind of be indented or you get weird behavior. See, look, Zelda has all her properties and then there's that list there. So just by indenting it, one space doesn't do it because it doesn't line up with breed. I have to have the right level of indentation everywhere. So YAML will annoy you. I just want to level set this because as we start working on stuff, if you're banging your head against why this isn't working or why this is working, it might go back to like check your YAML. Who remembers Real Genius? It's like always check your optics, like same type of thing. Always check your YAML when you run into a problem. Some other things that we can do that doesn't really apply to this example, but would definitely apply with GitHub is, if I have a run command and I want to do a multi-line thing, I can put a pipe here. And line 1, line 2, you see what it's doing in the comment? Line 3, if I do a shell. So when you have like multi-line stuff and you don't want it to be super long and you want it to wrap, you can do the pipe and do the multi-line thing. So just wanted to show that. So that's YAML. That's really all you need to know. You can do, I think it's this. You can do comments also because it's a superset. So, all right, so that's YAML. Any questions on YAML?
Any recommendations for converting to YAML?
Well, I mean, you can take, there are some that go the other way around. Yeah, there are ones that go the other way around. So you can just do the conversion the other way if you need to. And if you're coming from, and we'll get to it, but if you're coming from another system, there is a GitHub Actions importer that will help you import your like workflows from like Jenkins, I think, at GitLab or DevOps and stuff. All right, so next, I just want to talk about CI/CD because this comes up all the time. Like, what is CI and which CD are we talking about? So continuous integration, a lot of times, this is what I think about for providing feedback to people very quickly. Does it build? Do my tests run? Can I deploy it? Can I like look at it and do acceptance tests? Like that's CI, maybe I deploy it out to a dev environment. And most of that's automated. I'm not right-clicking deploying. I'm not hitting F5. I check in code. It builds it, and it tells me if the builds fail or have security vulnerabilities or whatever. The CD is where people have arguments sometimes. I always put it, continuous delivery is your system is set up so that you can push button deploy like all the way through. Doesn't mean it has to. Like you can stop it before it deploys to prod or QA and have a human look at it and a human approve it and say, I would like this to be deployed. When people start getting much more mature, they start going for the continuous deployment route where their tests are codified, their quality is codified, everything is already built into their pipeline. Does it meet your unit tests? Does it have code coverage? Did we run a security scan? Did we do a performance scan? Did we like run our acceptance testing, UI? Like if all of those things are met, why do you need someone involved? If your definition of quality is done and it's not a business decision, it's just like a patch, like you can push it through. So GitHub supports all of these activities. You can put humans in the process, you can trigger stuff automatically, like you have all of these capabilities and we're gonna talk about them. So actions live in the .github/workflows folder. So if you have a GitHub repo and like you can go to any popular one that has actions there, you'll find a .github folder checked in. This is very different from your .git folder, which is all your history. The .github folder is gonna have like issue templates and some other stuff, but the workflow folder is gonna have all of your workflows. They're all in YAML and they're event driven. And what sets this apart from like Azure DevOps and some of the other systems, you don't need to register them for the system to kick them off. Just by having a file that meets the YAML schema in that folder, it will try to execute it if it meets the conditions to execute. So if the right event happens and you have the right structure in your file, it'll just start running workflows, okay? Just by creating it. There are a lot of events that can trigger workflows. There are some that are code related, like I'm gonna push code, or I'm gonna make a branch, or I'm gonna fork it. But then there's some that are around the other parts. Hey, we have an issue. Somebody made a comment. There's a discussion. Somebody moved a project thing from one column to another. All of those can trigger workflows. GitHub actually made a training system built on actions. So just by forking it, that starts the training. We're gonna do some of that later on today. But they actually, and sorry, the creaking floor is not fun. Yeah, so they have this huge list. They're all over here on the side. There's a ton of them. And you can see clarity around like the activity types. So like for pull requests, what's interesting about pull requests is it's not just a pull request. It's also for a pull request, it was assigned or labeled or opened or closed or locked or ready for review. Like you can trigger a workflow based on somebody has reviewed your pull request. So you have some really cool capabilities for building a very custom CI/CD process for your organization. What's also nice when you have open and close means open, I can go spin up an environment. When you close it, I can go delete the environment. So you can have dynamic environments created just on pull requests. I'll show you one of those later. So any questions on events? Like we're gonna do some events, but there's a lot of capability there. So event happens. Could be a webhook, code push, an issue, some sort of event happens, and that triggers a workflow. And we'll show how the triggers work. But that triggers a workflow, and inside your workflow, you can have a job. A job is going to contain steps. You're going to have a lot of different steps. They can be GitHub actions, or they could be like run commands, like you want to do some sort of shell command, including PowerShell on Windows and PWSH on pretty much every platform. So you have capabilities to write shell commands. Each time a job spins up, it's going to be on its like own little runner. So it's you can do it on self-hosted runners, which we'll talk about, where it's like you made your own VM and you're running your action on that. But if you use the GitHub ones, it's like, hey, I spun up a new container. Here, I'm going to run some stuff. So it's like starting from scratch every time. So you start with a checkout or a downloaded artifact, you do stuff, and then you deploy it. Now, if that's all it was, it wouldn't be very interesting. We can have a lot of jobs. We can have up to, I think, 250 individual jobs, something like that. By default, they run in parallel, but you can set up dependencies. So you can be like, I would like you to build before you try to deploy, please. You can do things like that. Like, please test it before you deploy it. So you can have these jobs run in parallel, or you can have dependencies between them. Again, each job is going to have its own little runner, its own like self-contained identity. You can have one on Mac, one on Linux, one on Windows, doesn't matter. While the jobs run in parallel, inside the jobs, those steps, top to bottom, they are executed in order for a given job. So let's hit one or two more slides, and then we're going to do demos. Just lots of demos, and we'll start doing stuff. There are runners. So there's a little YAML command runs on. We'll look at that. But you can do stuff like Ubuntu latest or Windows latest or Mac latest. They give you a new VM each time, and during a job, you can like write a file and read a file, and all that stuff works. And when you're done, and the whole VM gets thrown away. They have all sorts of software installed, and we're about to see all that. So here's the repo for this talk, GitHub Actions demos. If you remember, I said everything's in the .github workflows folder. So here's a bunch of workflows. If you want to see how they work, you can go to Actions. So Actions is where you can make new workflows. You can see runs and history. So I'll just start with this one. Just start with a basic workflow. And let's take a look at what it looks like. So for this one, it's got a name. We've got on, push, pull request, and workflow dispatch. So on 3 different events, this workflow is going to run. And then we have one job. So we have an array of jobs. We have one job build, and it's going to run on Linux. So Ubuntu latest, that's where it's running. Let me just do this. And then we're going to do a checkout command, and then we're going to just run a script in bash, echo hello world. So that is my script. That is my workflow. And I can go here to Actions and click on this workflow. And see, I've got a little drop down. It says this workflow has a workflow dispatch. So out of the box, if you don't include workflow dispatch, you cannot manually trigger your workflows. The only way you can make your workflow run is if you pushed or did a pull request or whatever the trigger is. So if you want to manually run something, the special trigger is workflow dispatch. You're dispatching it. And it's asking me, like, what branch do I want to run it on? So I will run it on my main branch. And if I just wait a second, this is going to update an entry. I should see an entry. There it is. It's a little yellow dot. And I can kind of watch what's happening, or I can click on the job and actually drill down and see individual steps and actions executing as they go. Now, we only had checkout and hello world. This has a couple of other scripts, or a couple other steps. So let's take a look at this. So I'm actually going to get, just looking at my setup job, the runner version, the operating system. So I can keep track of like where this was built. And then here's the interesting part. the runner image with all of the included software, which should be running, but let's see here. I'll just go to main, runner images. Included software. Might have just been building or something on a branch. But this is going to list out like your kernel version, your installed software with all of the different versions installed on it out of the box. So like, let me go to, a Windows one. So we have Mac OS, we got a couple of versions of that, Windows Server. It's really cool when you look at it because you're going to see the exact build. You're going to see, like I said, PHP, Node, LLVM, Kotlin, Ruby. It's got Helm and Chocolatey already on there. It's got NPM and NuGet. It has environment variables for paths of some of the software. We've got normal random pieces of software that we're going to use for different things like Git or JQ or Subversion. We got CLI tools for Azure and the developer CLI. Random packages, browser setup with environment variables for Selenium, versions of Java, different shells. And then they have cached versions of tools. So if you do like Docker build, and they have cached versions already ready to install and go. It's kind of nuts because I know people spend a whole bunch of time and effort building and customizing runner images. And I'm like, for the most part, why bother? Like I just use one of these and it has everything already set up and configured and automated, and it makes my life so much easier. And then here's the PowerShell tools. So we get the version of PowerShell and the installed modules already listed. So pretty neat that I can just use that and do whatever I want with it. We've also got information about our token. So these have permissions, and we'll touch on permissions. Out of the box, the actions can usually read most things. You have to be a little bit explicit to tell it if it can write stuff. And then it starts downloading the actions that you've got. And we'll talk about how to find those in a moment. It's running a checkout, so it's just getting on my code, and then it's going to run the script, and I can see kind of the actual command that's being run against bash in this case. And then it cleans up. Like it cleans up things and then gets destroyed. So that's a runner, or that's a job, very basic. We can do a lot more complex things. So I mentioned that, we have all these triggers. Well, not only do we have triggers, we have filters we can apply to the triggers. Maybe we don't want our thing to always run for every branch. We only want it to run on main or on releases. Or maybe we just want to do it on certain tags so that if you have tag v3, it won't run the action. Maybe we want to ignore certain paths or include certain paths. So we only do a thing like update documentation if they change the docs folder, something like that. We can do that. And then you can specify which branches you might want to pull request in. All of this is documented and out on GitHub. So if you're, GitHub, trigger, not only do they have all of the events here, they have the filters for each of these. So, when I want to do a push, I can only when on a specific branch or only when a certain tag. So you can find that documentation out here under the events, under the triggers. Where was I? There I was. So we can do even schedules. So if we want to do a cron type schedule, we can do like a nightly build if that's something we're trying to do. So we have a whole bunch of power on that. So in addition to those filters, I mentioned that we wanted to have multiple jobs. And you would just define jobs just like before. So I have a jobs array, and I'm going to make a job object, and I'm going to do some stuff, and I'm going to make a different job and do some stuff. It's very easy to see these running and kind of see what happens. So if I make a basic workflow and I just run these, what's really, really cool is they have a good visualizer in GitHub Actions. So give it a sec to spin up. So I just told it kick off 3 jobs. So I've got a box with 3 jobs and some of them run. No dependencies, no nothing. If we change things to put a dependency there, job 2 depends on job 1. Job 3 depends on job 2. It's just basic dependencies. They actually update the visualization as well. So you have a very clear view of what is happening and what are the dependencies between these jobs. So it's going to intentionally wait to kick off 2 till 1 is done. It's going to intentionally wait to kick off 3 till 2 is done. So some of our first real customization of a workflow, and we can go to the workflow file and let's go see what happens. Really, it was just 1 line of code. You can put multiple jobs there. You can have comma separated lists here. So you could say this depends on job 1 and 3 or 4. And so you can start building those complex graphs of different tasks if that's what you're trying to do, separated by job. All good? All right. So now that we've got some basic jobs, we've got some basic workflows, why don't we, let's just go look at this one. And then we'll get into you guys doing some stuff. So steps. So we can do lots of things with steps. We can specify different shells. So pretty much every GitHub hosted runner is going to have something like a bash or CMD or PowerShell or Python as an available script, Perl even. You can specify actions based on like a commit hash or a major version or a major and minor version or a branch. So if you're doing internal actions, you might just do main or you might use a version. If you're using a third-party one that's out there in the community, I'm sure we saw what just happened with XV. So you might want to lock things potentially to a certain commit hash if something happens, or to protect just, against dependencies that get updated and you don't know what's going into them. So be intentional. But how do we, let's just run this and let's see what we get. And then we're going to go figure out how we find all of these different actions, because there's thousands. So let's just run this guy. And then we'll start getting you guys writing some stuff. All right, so steps. We got all sorts of different jobs running. We saw some things happen, some good things, some bad things. Let's go take a look at what happened. So bash, that just dumped out our path. I'm on a Linux machine. There is no CMD. We're not on Windows. So this just errors out. I put a continue on error. But even though I'm on Linux, it has PowerShell. But it doesn't have PowerShell. So just make sure you use the right shell, depending upon the platform. But you can use your scripts pretty much anywhere. You can just have direct, like, hey, I'm putting some inline scripts in place, running on whatever language. We've got Python, we've got Perl, and now the actions. So we got a ton of shells. There are some defaults, like Windows, I think, defaults to CMD. Mac and Linux default to bash, but you can override it. Okay? So if I want to find out how to get that version or that tag of an action, I can come up here to the top left. I just hit the little hamburger and I go to the marketplace. This is where all the actions are and documented and shown. So we can go to actions here and we can do something like, I was looking at checkout. So if I go to checkout, I look at that. We've got a checkout. These have a blue check mark. They didn't pay $8 for that one, so I wouldn't worry too much. We can see the current latest version. We can see that they have a badge about passing tests. I can scroll down and see all of the previous versions. If you want to have an action listed in the marketplace, it has to be open source. You have to be able to go see the repo, to see the code, to see how it operates and what it does. You can see the issues, you can pull requests. They have really good documentation. So the actions ones that come from GitHub and come from actions, super well documented. You will see how to use it. On pretty much every action, they'll give you a sample, like here's a use for it. So you can say with to pass an input or a variable into an action, and you can check out a different repo or a ref or a certain token. And then they usually will give you scenarios on how to use the action to do more complex things. Like, I only want to get one file. Well, I could say sparse checkout. Or I want to get all the history of tags. So give me fetch depth. So looking at the different actions, you can find some really interesting capabilities. A couple of people earlier on had said that they were interested in Docker. So if I look up Docker, we can see a couple of actions. So these are by Docker. So there's a Docker login, a build and push image. Here's setup buildx. So if I look at the build and push Docker images, I can see how many stars it has. They've got some badges with code coverage. I can go out and actually click on the repo. And here's the repo for it. And here's all the source code for this action. A little bit of TypeScript to help with some stuff. I can look at their open issues and pull requests. And so here's the examples. So I want to do maybe a test before push. This links out to theirs, but that's fine. So I'm going to do a build and load. I'm going to run some tests. And then I'm going to do that build and push action again with push true. So we can, on the runner, build an image, run our test on the runner, and then push it out to a repo. So how do we get there? How do we start passing those pieces of information into our actions? So one way is through contexts. So if I look at, through variables, and that's going to lead us to context. So most of the time, you can just put env down. So I'm going to get some environment variables, and we've got that key value pair, just like before. And when we want to invoke it, we want to use it, this is going to change based on your shell. So for bash, it's just $. PowerShell might have the PowerShell syntax for accessing environment variables. So this is very specific to the script you're running, but they are injected into the process. So they're environment level variables that run at the job, in this case, or the workflow. So if I run this, we're going to actually see a couple of interesting things. Trying not to move too much. Creaky floor. All right. So we had set up our job. And you can see the command line that gets run still has the $, still has the environment variable references. But you can see that the environment is getting injected into that command, and it's printing out what we wanted it to print out. And we actually have a bunch of different capabilities that we can do with this. So, like in this case, go to the file, thank you. I define some environment variables at the workflow level. Hello, workflow. You can define them at the job level. Environment job. You can also define them on the step itself. So what do you think is going to be the output of this? The narrowest scope. Another thing that you can do, which we will touch on, but you can, in your repo, if you go to settings, there is secrets and variables here. So, for our actions, we're going to talk about some secrets and stuff, but there's also variables. So you can have organizational level variables, you can have repo level variables, and you can have environment level variables. So you have a couple of different things that you can do to really kind of customize this. And we're going to explore that once I get you guys building some stuff. So let's go back to the runs of this and run one. And I can actually, if you haven't used a GitHub Actions extension, there's a GitHub Actions extension. It's really cool. I can see, this running from here. I can see the jobs kind of running as they go, so I can get updates. But the other interesting thing about this extension, I can go look at the repo level variables from here. And I can edit them and tweak them from here. So if I'm iterating and building a workflow and I want to see what's happening or tweak stuff, I can do that right from the extension. So you said it would be the most specific thing. Let's see what it says. Hello world from step. And we can actually look at what got injected. The job level variable got overridden by the step level variable. So it's the closest in wins, or last in wins. So the most specific or the closest to the area of execution. If I printed out something else, it was the other job. It was this job. The second job, I didn't pass in some variables, so it didn't carry over from one job to the other job. So it left out the name because I never set name in my second job, just to remind you real quick. I had set some stuff here, but I didn't set it down here just to see what carried over, and only the workflow level values got passed in. So just something to keep in mind, like, did you set the variable? Did you not? Did you set it at a different level? So I mentioned at the beginning that GitHub made a training platform. It's called Skills. So if you go out to skills.github.com, let's just get you making a basic workflow, because we are going to do a more complex one later as we keep building on some stuff. So if you go to skills.github, we can do hello GitHub Actions. This is a pretty basic one. You should see it in the list under like automate workflows with GitHub Actions. So you'll see hello GitHub Actions. And if you read the README, you're going to create a workflow, add a job, add some actions, and merge your pull request. And the way you start is you hit start course. So this actually just does a fork. And this will kick off an action that changes the README on the main repo. So as you do a step, it'll update the README every time. So it says, hello, let's go ahead and do this thing. Make the prompt. After it's created, wait 20 seconds, then refresh. So I just forked it. I'm going to wait a little bit. I'm going to refresh. And hopefully, there you go. It just tweaked. It just changed. Step one, we're going to do a thing. So I'm going to give you guys like 1 or 2 minutes to start working on this yourselves. And then I'll go through it just so you can see what to do if you get lost. Okay? Any questions so far? This should only take about 5 minutes for us today. And then we'll keep going with some more complex stuff. And if you're curious how the sausage is made, you can go and look in the .github workflows folder. It's all there, but this is a really cool way of doing it because it can react when you make a PR or when you put a comment in. If you do the thing it tells you to do, it can trigger that next step. All right. So we're going to make a new pull request. So we're going to create a pull request from welcome workflow into main. So I'm going to go ahead and create my pull request. And this says, let's make the .github workflows folder and make a new welcome YAML. So we're going to change branches. And get over here to our workflows. We're going to make our new file. All right, so we made our file. Wait about 20 seconds and then refresh this page. All right, let's see what happened. So we didn't have any jobs. So now we got to add jobs. And please raise your hand if you get stuck at any point. So I'm now on step 3, so I'm going to add actions to my workflow. There we go. So we're going to merge in my pull request. And we'll just wait a couple seconds for this guy to run. So now let's make a new branch and test out our new workflow. make a change, create the pull request, and see our action. So we're making a pull request. Who has GitHub Copilot access? Who's using Copilot? What's cool is you have this little icon here when you make pull requests. I don't know if you knew this. You can click it and tell it to make a summary of your code changes as the description of your pull request, and it will write it out. And then if it's a bigger pull request, it'll actually link to the parts of the file that you changed. It's really cool. What step are you guys on? 3 or 4? Just wrapped up? So if you did it right, you should open a PR and should be able to see an action saying hello and welcome to the repository. All right, so let's just take apart a little bit. I know it explained it, but we've got our trigger. We're focusing on open pull requests. So that the script they gave us is going to run every time someone opens a pull request. We had to give it explicit permission to be able to change the pull request. So that's what that does. Permissions, pull request rights. The action is allowed to write to your pull request, which is what it did. It wrote that little message. And then it's running on Ubuntu, but it's just running a shell command. And what it's running is the GitHub actions or the GitHub CLI. So it's doing the GitHub CLI PR comment, and it's saying, go make a comment to this PR. And it knows the PR of the current run because it's getting information from this thing called github.event. And that we're going to talk about this a little bit, but this is one of the contexts available when you're writing actions. We have context around those variables. We have context around secrets and environments. And we have context around GitHub itself, like the events that triggered stuff, like how you got to the workflow you're at, like if it was a push or a pull request or a merge, all that information is in the .github event of the running workflow. And then the token is just a short-lived token for that run of the action to authorize it. So pretty neat little example. We're going to do some more complex ones, but so we messed with some variables. We saw what happens when you trigger something, but what if you want to run jobs or actions based on a condition? Like we don't just always want to run deploy to production. We want to maybe only do a deploy if it's on a certain branch or a certain condition. Well, we literally can do if. So if some condition is met. So, and you can look at all of the cool capabilities of conditional step. So in the documentation, using conditions to control it. So there's lots of samples like, hey, if my thing is not a tag, if my GitHub ref does not start with tags, don't run it. Or only run this if my repository is blah. Oops, stop bringing that up. Thank you. So you have a lot of capabilities to control execution. Maybe you want one big pipeline and you want to have some jobs or actions skipped if it's not main. You can do that. Maybe you want to have a job only run if it's tagged. You can do that. So tons of flexibility. This is a really big toolbox of capabilities. And what happens when you run one and things are conditionally on or off, you actually see it in the UI when it executes. So it's very easy to come back and look at this and go, oh, that didn't run because of some conditional. So you can see right there, we only say hello, we don't say goodbye. And so that got skipped. All right. And as you saw with that example around if, we have expressions. And not only do we have expressions, GitHub Actions has some programmability. So we've got the double handlebars. Like this syntax kind of is used throughout GitHub Actions for variable substitution or just showing expressions like env dot or format or ends with. You can do contains. You can do stuff like from JSON or to JSON. You can do joins. So all of these are very easy to access and use. So, using jobs, if I come down here, expressions. Again, I'm just searching up the thing I'm looking for, expressions. So we have all sorts of capabilities around using exact literals. So we can do numbers and hexadecimal. We can do strings. There's grouping and less than, all the normal programmatic stuff. But then we have functions that they offer. So there's contains and our object filters, starts with. So depending upon the customization or the crazy things you're trying to do with your pipelines, you can do all of those. All right, so let's just move on to context. So we touched on them a second ago. I'm just going to run this to show you what is in some of these contexts because it can really drive things that you're doing. So, and I'm going to come back to GitHub, but we can see the state of a job. So we can trigger stuff if it was successful or not successful. So maybe we want our test step to always run or our code coverage step to always run, even if our test step failed. We can respond to like job success. We can have outputs from our individual actions. We're going to get into those very, very shortly, where maybe we build an environment, but we don't know the URL. So in our step where we deploy, we got to go look up the output of that deployment. Maybe we need information about our runner to know what OS we're on or what architecture we're dealing with. We also have matrix builds. So there's a chance where you can fan out and have 10 or 20 jobs all running because you're testing things under different versions or different scenarios. And so the one I skipped, just because there's a lot of information here, this is the GitHub one. So like I can see like information around my events and like who did things and information about the URL and owner, and like there's a ton of information in here that you can leverage to know about the repository, the commit, the changes, and the things that trigger it. So let's actually start getting into some runs. I'm gonna skip ahead and I'll come back. Oh yeah, I'm sorry. Yeah, when I was doing context, essentially I was just doing a to JSON, but you have a ton of properties on them. So like I said, the GitHub one, you're gonna see information about the currently running action and all that. It's literally just, I did $ brace and like .github to show the, or yeah, just to JSON GitHub or to JSON the job. But you can go and access, like, I want to know the GitHub.action. I want to know the GitHub.actor to see the person who ran it, who triggered the event. I want to go see the GitHub.baseref to see the base reference. I just did a to JSON to dump it out. Yeah. The event is a very interesting one because you can actually see all of the contents of like the before, the after, the commits. Like looking at the contexts has a ton of information to give you all that more detailed information. So we're almost done putting all the pieces together. So I'll just throw in a matrix real quick. So matrix builds are really cool because they let you have a build strategy. So our strategy is going to be, we want to do a matrix. We want to build this, maybe I'm building a library and I want to build it 3 times for Windows and 3 times for Linux. And I don't want to sit there and copy and paste over and over again. I know that I want to use environment variables or some sort of variable from a context to switch my OS or to switch my node version. So I can say, here's my strategy, my matrix. Here are the versions I'm leveraging. Here's my OSs that I'm leveraging. And then this part pretty much becomes a template. It's going to copy and paste this part internally like 6 times, 3 times 2. And so we can reference, hey, use this OS, use this version of Node, go do this thing, and just run through my tests and loop through. It's really great for if you have to support multiple versions or multiple operating systems or do something where you want to test things multiple times. But you can use it for anything. It doesn't just have to be versions. It could be maybe a list of projects and you're going and building them in a certain way and you just want to pass an array and have it go fan out and do its thing. And so if you look on the left, you can see all those jobs, are starting to kick off. And I don't have to worry about writing out each of those individually. I can have the exact same steps run every time and know exactly what's failing or succeeding. But that goes back, like I just said, to the context, that matrix context. Another thing to notice, the Ubuntu ones finished very quick. The Windows ones take a little bit longer. There's also some cost implications. So minutes, I think that's the right term. So an interesting thing is, like you get free minutes and free storage and stuff, but depending upon your operating system, it actually has an impact. So the Linux ones are the cheapest, the Windows ones cost twice as much, the Mac ones cost 10 times. Yeah, so, I mean, the permanent rate is usually very, very cheap. It's really pennies on the dollar, but just something to keep in mind. If you need to do a Mac builder to do like an iOS app or something, and you have to have Xcode installed, you might be paying for that. Just FYI. All right, so they all finished. Cool. So we saw in that matrix that it's just doing that same double brace matrix to access it. Well, let's look at the other ones that we can leverage. Let's say we want to do variables. Variables are the same way. Dollar, double brace, vars. So this is that org level variables, those repo level variables, environment level variables. We're going to access those through var. So, var is, one context. The first one we saw written down was env dot. So we have a couple of different ways we can access them. I do like the repo level stuff because it makes life a little easier for some stuff. If all the workflows in your org need your API key, you can put it as an org level variable or an org level secret. And then everybody in the org can access that same secret. And you can give them permission. But then let's say one team has their own thing. They can overwrite it. So you can have an org level secret or repo. You can have a repo level 1. You can have a job level 1. So vars from repo. I don't have an org level 1, but I can override variables. I can change them. It's all very easy to manipulate these. So secrets. This is the one where there's actually some caveats to using secrets. You probably think, oh, I'm just going to throw it in like a variable and I'll be fine. Well, GitHub put a lot of work into not logging your secrets, like not printing them out in your logs. Like you'll see stars in some of my stuff. So you get the secrets by going to settings, coming down here to actions. So you can see we have these secrets, and this is saying here's my environment ones, which we'll come back to. But then we have our repo level secrets. So I can just make a new repo level secret, blah, and paste in some stuff. You're going to see this a lot on demos for authentication. Be like, hey, paste in your Azure credentials here or paste in something here. You can also do it through the CLI. You can also do it through the Visual Studio extension. So I can't see what those are, but I can come in here and I can add a new one. Now, once I've added my secret, if I try referencing, something that doesn't exist, let's say I did like Azure Client, it will just come back as an empty string. It's not going to give me an error that I asked for a secret that doesn't exist, because let's say someone's contributing to your repo and they can't see the secret screen and they're trying to guess what your secret is by just plugging in different names. It's not going to give you an error. It's just going to come back with an empty string. So if your actual secret is an empty string, or if there's actually one there, it's just going to return an empty string or the actual value. But like I said, you got to be careful with how you use secrets. One thing that I try to do is you can run this type of command right here, where you're actually passing the secret on the command line to the thing. I try not to do that, because if like someone could look at the processes running on the machine and your secret be right there on the command line. A lot of times I will try to set it as a variable, environment variable that way, to just limit exposure. Something else to be aware of is structured data. Structured data. So let's say you're like, I'm just going to put my JSON object in my secret here. Depending upon the formatting or the way things get structured in the output, GitHub might or might not block it out like it's supposed to. And it's especially if you take a structured secret, pull it apart, and then pull one field out, GitHub is not smart enough to stop you from doing things. So if you want to shoot yourself in the foot, you can. So be very aware of like how secrets are treated and how they execute. So that's one reason I built this little demo, because it's kind of enlightening to see what happens as GitHub runs and blocks things. So, if I just pass that context, see, it's kind of gotten smarter. Like you can see the environment variable I sent, and it realizes that's a secret, and it blocks it out. But if someone had somehow did something on the machine, they might have seen that. Here, you can see you're only doing the name of the environment variables, and it does block it out from the logs. Like it's stopping that. I have this, you can tell that was a structured object. So I'm saying echo blah, blah, blah. This changes the structure of it. So it's smart enough to block it out in the command. But when the output, oh, look, there's my client secret. Because it's not smart enough to realize the output was changed by echo. But if I pass it in the environment, it's a little smarter. So you got to be careful with these. And then if I start parsing stuff and printing it out, it's not going to stop me, because I passed a partial thing. So be very aware of how you leverage secrets. Don't just treat them like an extra string or an object. You can break GitHub's protections for you if you're not careful. And nobody wants that. All right, so I didn't talk about environments yet. So let's get to environments. And then we're going to start working on some work stuff together. So GitHub Actions has some cool environment stuff. I don't think that their protections are as robust fully as like Azure DevOps, where you have a whole bunch of approval flows and things. They are working on it. Like they are making new rules and rule sets for protection of your branches and protection of environments. But you want a new environment, you go to Settings, Environments down here under Code and Automation, and you can make a new environment. So I have an environment, I'm going to call it, PowerShell Summit. And so I can do a couple of things. I can have required reviewers. I can stop myself from approving my stuff, so I can list out 6 people or teams. I can tell it to wait a little bit in case you need to go stop it because you find something. And then here's the new beta thing where you can make some new protection rules. So these are newer. They're still fleshing it out. Like I said, it's in beta, but I was trying to find the. Thought I had some samples of some protections, but you can also limit which branches can go to it. So let's say you make your prod environment, and you say only main can leverage prod. You can do some limitations there, or say only protected ones, which means they have to have a pull request into them. So you have some control over how you can leverage the environments. But then the environments can have their own individual secrets and their own individual variables. And they tell you use the vars context. So I have a number of environments here, and I do what I do in most CI systems, where it's something like, hey, I have a dev, and I have a couple of secrets here, like my resource group and my subscription. And then I have my prod, and I have a couple of variables that are named exactly the same thing. Because now I can just use a template or copy and paste a section, and it's using the exact same variables. The only difference is the environment name. That's the only change I need to make, because it's going to react to the environment. So, for instance, I think issues code. Let's go back in here. I think this one. Nope, that one doesn't do it. Oh yeah, here we go. So environment. So I really just need to change that to production or dev, and it would pull the relevant variables out. So, and secrets would pull a combination of org level secrets combined with the resource levels or repo level secrets combined with your environment level secrets. So you don't have to tell it, go get the org version of this and the environment version of that. You just access secrets and you don't care where they come from. It's gonna funnel down and give you the most relevant secrets. So yeah, let's start looking at some of those real world scenarios, and then we're gonna build some ourselves. And then we're gonna circle back and start hitting some more advanced topics. So like .NET, this is a very basic pipeline. I do stuff like this all the time. I have some additional little things here to maybe not run my .NET pipeline when I touch my Docker image. So you can say, ignore everything and then add in .NET. So if you're trying to do a single repo with multiple projects, you can say stuff like, ignore that one, but look at this folder. So you'll see this syntax in a lot of my samples here, but it's designed for my samples. Another thing you'll see is I have permissions and I have ID token write. So a lot of samples you see logging into Azure will use that Azure credentials block. We're going to talk today about using workflow or federated credentials. So where you can have no secrets, no passwords, and it's really locked super tight down to your repo, your branch, your environment. I'll show you how to do that, but you have to give the action token right. You can also say, hey, I want to run in this working directory. So I can set defaults. So every time I do a run command, I can set my working directory. That way I don't have to set that on every single command. I can set it one time, and that will set the default for my workflow file. Everybody's going to use the same working directory. So I'm on Ubuntu. I check out some code. I tell it I want to use .NET 8. You know, at the time I had 7, and now I'm on 8, and so cool. I'm doing caching. So caching is really neat. I like using caching, and I'm going to show you this action because it's a really cool action. If you have a really large project and you're building and doing all sorts of stuff, you might want to back up your NuGet packages and then restore them That way, like the next build and the next build don't have to download 100 megs of NuGet packages or npm packages or something. Well, you can cache all sorts of different stuff, and then it will restore them. But what's awesome is you scroll down a bit and you get here. So I want it to do like, oh, I'm doing a pip, some Python. I'm going to do some AI work. How do I use cache? Well, I can just do this, and it will cache all my Python stuff based on requirements on the OS. And then when I run it again, the next job, it'll restore it because it's already pulled down all the pip images. Same with NuGet, same with Python, or Node, .NET, whatever, Java. So this is a nice little action to help speed up stuff when you're doing a lot of runs at scale. I'll show you where you find that, but it's very easy. Then I'm going to do a .NET restore. I'm going to build, and I'm going to run test, and I'm going to publish it out to a folder, and then I'm going to upload that folder. So I know the path, and I'm going to upload that folder as an artifact. And what this does is this is actually how I'm going to get the binaries from one job, my build job, over to my deploy job. So this is my web app, this is my infrastructure. I'm going to upload those two artifacts. And in my next job that needs build, it's going to download those artifacts. And it's going to log in. If I successfully log in and I successfully deploy my infrastructure out, my infrastructure is code, I give it some variables, I give it a bicep template. I'm even overriding some of the parameters based on a secret. So it's going to go create a web app. And at this point, I don't know the name of the web app. Like it based on a variable and whatever they do inside the bicep. So I don't really know the name. So if I want to deploy to it, I have to say, hey, my app name is that deploy step, output, web app name. And the reason deploy works, you have to give it an ID. So you have to, just like with CSS or JavaScript, like you have to give an ID to the element so you can reference it later. You have to give an ID to your step so that you can reference it later. So whatever I put up there under ID is what I would put here to get it. And there's all sorts of ways to pass between jobs, not just between steps. But these are some of the cool capabilities we can do where we just dynamically create an environment, get the name of it, pass that to a thing to deploy it using an output. Any questions on this? I know there's a couple of new concepts there before we start building some of our own. Okay. And I'll just go ahead and run this just to show you. And then we can even make a change and watch it trigger. So we have our two jobs. You look at our build job. Running checkout, we're running setup. Did caching, so it didn't find it. So it's gonna just watch it in case I run it again, it'll pull that. Get our build. So if we look at the uploads, one of the cool things you can see is it's going to show you, like, it'll zip it up. It'll tell you how many bytes it was. And it'll give you a hash of it as well. So you get information about the artifact that's being uploaded. You have some additional capabilities you can do if you want to change compression and stuff. Both of those got uploaded. And now if we go back to our other job, our deploy, it's waiting on approval. So I had said for my .NET environment, I want to have approvals. So I actually have an email telling me I have an approval. There's a little notification up here that'll tell me I need to do an approval in my notification box. I have too many repos. But yeah, so somebody can come here, they can approve it, and that will kick off the job. So I put that approval, as I showed you before, on that environment level. So now that I've approved it, it's setting up the job and it's doing the thing. But any language, any command, anything you need to automate, you can automate pretty much this way. Like if you know the instructions to build it, the .NET build, the Docker build, Docker compose, like you can do those steps and automate them. So it's downloaded this artifact. I can see the same size and ID. I could add like an LS there if I wanted to verify the files. I got the sign in. It's using my federated credentials. And we're going to circle back to this, but you'll see repo. So my org, my repo, my environment. So it knows that it's coming from this repo, from this environment. So it's identifying to a user service principal in Azure, very tightly coupled back to this. And I can give that identity specific permissions. Like the prod branch goes to this identity that can only talk to this subscription. And the dev branch has a different identity that goes, like, we're going to get into that. So, yeah, and there was the ARM deploy, and you can see parsing outputs. So it knows there's going to be some outputs there. Any questions on that? Because I want to get you guys building some stuff again. Something a little bit more complex. I mentioned Docker. Docker is very basic for some of those things. You can do more complex stuff. Like we can do a Docker login. We can log into Docker Hub. GitHub also has a package manager. They have their own registry. So you can push Docker images straight to GitHub. You don't have to go through Docker Hub. And then, yeah, we can do containers. We can have multiple tags. We can access the SHA hash by just using that GitHub context, GitHub SHA. Boom. And then we can research that Docker build and push if we want to do like a test example. Whoops, I meant to hit the other button. Yeah, all of the major base images and a lot of things are already pre-cached on the GitHub runners, so it's not pulling down like Alpine and some of the other bases. Like it's just automatically going to have them on the machine when it spins up, so that it can build and push in like 2 seconds. Yeah, how long did that actually take? 7 seconds. My bad. All right, and let's go ahead and do a workflow. We'll do a couple parts of it, and then we're going to come back. So let me bring up my slides because I have so we're going to work on this. I made a tiny URL for it. This has like 5 parts. We're going to do the first part and stop, and then we'll work on the second part. So it's under github.com actions workshop /actions workshop. But you can get to it with that tiny URL, GitHub Actions. Whoops, sorry. Go away. There you go. Everybody get that okay? All right, so what you should see when you go here, is if you scroll down, you should see a floating octocat. Octonaut. And this is going to be very similar to the first one we did, but we're going to build on it. So we're going to build on this a little bit. There's a couple of different steps that we're going to go through, because we're going to do a continuous build and test, and then we're going to start packaging and releasing stuff. And then We still got some semantic versioning we can talk about. We've got some more security stuff. We got Dependabot, all sorts of cool things to talk about. So only about a third of the way through. So we're going to use this template. Whoops. So we'll give this 5 minutes and then we'll see where we're at. All right. And if anybody needs to take a break, we can take a break. There's somebody I used to work with. They said you always have the right to pee them. So if you need to hit a bio break or do anything like that, please be my guest. There is an official one at 3. Okay, I forget about that. So we got about 10 minutes till the official break. So thank you. How long is that for? 30 minutes? All right, perfect. Yep, we're doing part 1. If you want to start going into part 2, you can. That's fine too. Just trying to get you guys used to interacting with GitHub. It has some quirks, and so the more you interact with it, the more things start to click, I think. What's interesting about the editor, if you're doing it in the browser and you're trying to add a file, if you type GitHub and then you do /, it will actually do the folder. So that you can, like, you don't think about it when you're first using it and typing it, but then it like just kind of works. You're like, oh, that's interesting. Yeah, making sure everything's indented is always fun when you're doing all the copying and pasting. So that's why we went over YAML first. Because you will get red squiggles and you'll be like, why? All right. You guys are such a quiet bunch. Anybody have any problems? Is this making sense? Or is it, you guys doing good? All right. Because we get to the really cool stuff next. You have to lay the foundation first. See, and in the back, you were asked earlier, how do you know what made a workflow trigger? Or how do you know what made it happen? Notice this says manually run. This one says issue 10 open. So I added an issue trigger. So that's telling me the event that triggered my workflow.
So we were trying to map from a use case I had in Azure back to this, where
Okay.
I had a pipeline that would trigger a check-in for this piece of code. And this other pipeline was watching this pipeline.
So you're doing the workflow call, workflow run type thing.
I don't know, sure.
Okay.
But so there were two pipelines in Azure, and one was being triggered, the other one executed. And so, unfortunately, that wasn't a good way for me to know. It detected the trigger, but it didn't know code-wise to try to figure out which. There was 4 pipelines that could trigger this one.
So okay, that's a slightly different thing. But yeah, we can talk about it. Just like the workflow dispatch is how you manually dispatch jobs, there's a thing called workflow call where you can just call another template, but you can actually give it an extra little bit of information, like here's where I'm coming from, or here's a discriminator or a bit of information. You're talking Azure DevOps? You were just saying Azure. Did you mean Azure DevOps? Okay.
Convert from that environment, we wanted to move to something like this and try to
Yeah.
add. And so what I ended up having, what the solution I found at the time was the environment variables are patterned. And I was able to deduce from the, so I had a small task in the first part of the pipeline that would go through the environment and it would figure out which repository was being called. And I just used the whole right hook.
So you can call other workflows, and we'll get to that, but you can give it a with. So you could set extra variables or secrets, and you could tell it, hi, I'm the one calling you. Like there's actually a trail, the workflow, we'll talk during the break. That's fine. Well, we'll talk during the break. All right, everybody done with 1, or are you still working? All right, so it is 3, so you guys can keep working. You can go take your break. We can chat. Do you feel a little bit better about like just understanding what's happening when you look at a workflow file now? All right, so who's ready for some more advanced stuff when we get back? We'll talk about, like I said, security and scaling and templating and all the cool stuff. So see you guys back here at 3:30. If you want to chat, we can catch each other and chat. All right, so we left off, you guys had hopefully just finished part 1. And when you make an issue, this should run if you did the extra stuff. So that was part 1 of what we were working on. So next, we can do the CI/CD part. And this is where things get kind of cool because, you know, I've been giving you some samples. We've been getting workflows to start from. What this one really starts with is using the starters that exist inside GitHub Actions. So if I just come up here to Actions and I go New Workflow, there's a ton already out there that they've already kind of figured out, but you can search. So this has a sample in Node.js. So I can search for Node.js, and there's a Node.js action, just right out of the box. And so I can configure this guy. Let me just zoom it down a little bit. And it's already got a bunch of things set up to set up Node, run my CI, run my build, and run my test. So I'll do this one, you guys, just real quick so we can look at what's happening. And you know, we made this, and we want to check it in. So save it as Node.js YAML. And I also suggest that we remove the 14 because that is old. So we'll go ahead and check that in. I think I might have. And so without any real work, we've got a Node.js build running that's doing our CI and our build. So we're going to see this capability exist in lots of languages. Like if you have a repo with .NET and you go to new workflow, it'll say, hey, I think there's some .NET here. Same with Java or Maven, but you can search for your specific thing and it'll help get you started. Now what this thing is cool with is it's going to help us do our testing and understand what's happening with testing. So that ran npm test, and like I don't want my developers, my users have to go into an individual action, into an individual run and kind of expand tasks trying to figure out what was my code coverage or what was my testing coverage for that one specific task. Like this is not cool. Like this is where we can kind of take some of that hello world PR stuff where we're updating our PR and we're going to combine it with this so we can add more testing. And that's what's cool. What was this? We're going to be able to use an action. So this one, this Vitest one, again, it's all in the stuff. You guys can follow along. This one is going to let us publish our results right in the PR, in the workflow. So if I come up here and search for this guy, there's the action, and it's going to let us take this and just like before, how to configure the stuff and then how to run the commands directly in our workflow. They gave us our sample. Like this is kind of what we need. Now this does tell you exactly what you need to do. They've already kind of done the work. We've got to expand out our permissions so that we can update that pull request just like before, just like our other kind of hello world. We're going to go to our workflow, edit this guy. I routinely will get into the like 20 or 30 builds, like multiple runs. Like I do not expect in any way, shape, or form to have a perfect pipeline the first time I run anything. Like even basic like building.NET, I'll do double digits the first time. Like you forget the syntax, your indentation's wrong, you have the wrong variable, you got to update the path. Like all that stuff is normal. Like don't let progress be the perfect be the enemy of good, because that is something you have to fight. Because you want to do a thing and you want to get it just right, and they're even suggesting, hey, let's tweak our name. So I'm just quickly making these changes, and we're gonna check them in. And what we should see is we got our node file running our builds. But this is great for library builders. A lot of times we don't need this. So this is even telling you like, let's remove the matrix. So there's a couple of things that you have to do to like go back from the matrix builds. I actually screwed this up the first time I did it when I first ran this, because it's easy to come down here and go, well, I don't need the matrix stuff, and I want to just keep like 18, for instance. Don't need that, don't need that. Just do 18 instead of the version, or I could turn that into a variable so I could make it real easy later. Like that's actually a good idea. Let's do that. So we can do env, node version, something like that. Actually, let's just take their name. That's a better name. So we can just use the environment variable instead of the node. This is what I forgot when I did it the first time. I forgot to take out the strategy. So now instead of a multiple build, we should just have one build that just nicely, quickly builds 18, and that's it. Boom, boom, boom. All right, now this is where the fun part begins. So this is saying like, let's make a PR and see what happens. So this specific task that we added, we're doing a PR comment essentially. But if we're not doing a PR, we can't see the results of all of our work. We got to play with it. So let's make that PR change. Let's go into source. Go here. We'll just edit this guy, put in a comment, and commit this to a branch. And then we'll open up a PR with the Copilot summary. Gotta do the Copilot. Minor change to the file, a comment was placed. So now that we have that PR, what you'll see is that check automatically ran because I did a PR. So right here in my PR, I'm seeing updates to the actions. This is called like the checks API. So this should post all of our test coverage as soon as it's done. So something I haven't addressed that we will talk about. So there you go, look, I got code coverage right in my PR, so I don't even have to go and hunt for that stuff anymore. There are different actions like this for all sorts of different code coverage tools. I use Coverlet in .NET, and I can export it in certain formats, and then there's tools that will be like NUnit and JUnit files, and they'll support like any sort of NUnit or JUnit file that you can attach to the PR. So you have lots of different capabilities to make reports and then attach them to your PR. So it's a very easy way, or like put them on an issue or a comment or something like that. Now, what I was getting at is we haven't really talked about, we've seen all these different capabilities. We can use actions to update PRs. What we haven't talked about is conflicts or concurrency. You know, when you're building code and you're deploying out to dev, who has more than one developer in their team working in dev? You ever run into a problem where people are deploying and someone else deploys while you're deploying and they just kind of both like step on each other? You ever had that happen? So we can stop that with the pipelines. So the idea in GitHub is called concurrency. Okay. Helps if I type it right. So there is a concurrency keyword that you can do. And they have a couple of scenarios for it, but including like canceling in progress and stuff. Just right at the top here, you can say concurrency. You can give it a group. So you could have your concurrency be based on like an environment. Like, hey, I only want one thing across all of my jobs touching dev at the same time. You can like give it a name. Be like, hey, this is my .NET app. Only one thing can do my .NET app at once. Cancel any other ones. So you have a lot of different capabilities around that concurrency where you can limit 2 or 3 jobs stepping on each other at the same time. So as you're building these complex things, concurrency will come up. So somebody asked you earlier, I want to know how to test actions. And to that, I say act. So this is a tool. There's a repo here called by Nektos, N-E-K-T-O-S, Nektos Act. It's really neat, like, and I'm going to show you running it, but you can pretty much pull down a repo, and with Act, you can give it any event you want and simulate what happens. So you can be like, I would like to run this workflow with a push. Let's say I pushed to main. What happens with this workflow? I want to PR on this. And so you can give it the exact workflow, event. You can give it the payload that you want to do and run them. So, all right, this can go away. So I have Act installed here. So I can do -L. This is actually listing out all of the available jobs and the events that triggered them. So like push, pull request, workflow dispatch, you know, there's different jobs. So I could execute something like, hey, I want you to run 0 basic multiple jobs. And when the first time you run it, if you've never run it before, it pulls down a Docker container. It's going to ask you, do you want a small runner, the medium one, or the large runner? The large one can be like 20 gigs. So the medium one's, I think, like 1 or 2 gigs. It has some of the tools. It doesn't have all of the tools. And then there's a small one. So you do need Docker locally to do this. But it'll handle, you know, I can pass it whatever workflow I want. I think it's H, there we go. You can do secrets. So there's a way you can simulate the secrets and variables. There's a lot of flags that you can do with this. So caching them, being completely offline. So this is how I iterate locally a couple of times before I push it. Yeah, there's the environment. So like, here's my environment variables I want to pass into the thing. Let's see if I can do the graph. Generate a graph of dependencies. So that one's kind of neat. So that differs from that, where they're all the same. So you can get the visualizer aspect of the GUI before you even have to push it up and run it. So that's Act. Definitely something to check out. Again, you do need a Docker and kind of a probably more powerful machine, but this will walk you through it. There's a guide on like tweaking runners and instances and how to get it set up in different places. Really cool stuff. Has anyone heard of Act before? No? Okay. Another thing, you know, so we talked about security for a bit, about using structured data. One thing is, make sure that you actually register the secrets you use. There are people that like start using environment variables and then they like start putting secret stuff in there. Like, don't do that. Audit how your secrets are handled. Try to be very explicit in scope. Like, we've got the capability to do org level stuff, repo level stuff, and then lock stuff into environments. Use those. Regularly check and audit them. You know, I mentioned a lot of times the recommendation is to use an action instead of a script. Actions are constantly updated, so they constantly tweak them to handle new situations, new security, new scans. And if you just have a CLI script in your workflow file or in the file system, you might not update that. You might not think about it. You know, you might not be on the team that handles like new versions of login or checkout. They're on like version 4 of checkout for GitHub now, and like they've updated the login versions, and they update to newer versions of Node and things. So like they use that. like I showed you with secrets, using an intermediate environment variable instead of just passing it straight in. And we'll talk about OpenID Connect. So we're going to talk about deploying to Azure, logging into Azure. And then finally, for some of the third-party actions, if you don't trust them or are worried about things like XV, you can lock it to a commit hash instead of just like a major minor. So I mentioned things get updated. Who uses Dependabot? Who knows about Dependabot? A couple of hands. So Dependabot is awesome. If you don't know what it is, when you have a repo and you enable Dependabot, you start getting stuff like this. So Dependabot can regularly scan your repo and look for out-of-date packages. So like Semver, it automatically made a PR updating Semver from 6.3 to 6.3.1. So I can come in here and go, well, here's 6.3 to 6.3.1. What was going on? Well, with 6.3.1, they fixed handling a white space. Like it actually links to the notes. I can see the change log of what happened in previous versions. You know, I can look at the commits that they did building that version. And then, you know, Dependabot actually lets me do stuff like, hey, I want you to rebase this or squash this. Like I can give Dependabot commands. But if I just go look at what changed, this made one commit, and I went to my package JSON, and it was like, hey, you were using 6.3.0. You should be using 6.3.1 because it's the latest. So I can go test this, I can pull it down, I can run it, I can just hit approve and it'll merge. So Dependabot has a ton of configuration. And it used to not work with GitHub Actions, but they expanded it. So they actually added capability to scan all your actions. Where was it? Oh, here we go, supported repos. So Dependabot, there's a Dependabot YAML, I'm gonna show it to you, but you can enable it with like Bundler or Cargo for Rust or your dev containers or Docker. They'll even tell you if you have like an out-of-date base image in your Docker files. It can look at submodules and say, hey, you need to update your version of the submodule. It can look at your actions, your Java stuff and NPM stuff. So, and this works in private and public and different types of registries, even Terraform. I'll tell you about Terraform modules. And so what this looks like for us is in our .github folder. Pretty much everything's in .github folder. Here's my Dependabot. And all I said was, hey, for GitHub Actions, look for everything in this repo weekly and tell me if I have out-of-date actions. So before this workshop, I closed some PRs. Like GitHub Pages and Login and CLI. And so what did it do? It actually went through and was like, hey, you were using app v1, you need to go to app v2. So it's automatically keeping my workflows up to date, protected against older code. Very easy to enable, very easy to set up, automatically makes PRs for my stuff. Yeah.
Is it better practice to like specify the version that you're using?
So you can do at main, but I usually don't do at main. I usually do the like at a major version, because depending upon the organization, depending upon the group, sometimes people put not released stuff in main, and then they like make a version branch. So if you're on at main, you might get something that, you know, is pre-release in some way. And if you're on at main, you better trust everybody who can commit to that. Every single person. Yeah, that's why for third-party stuff, they're like, no, at full commit hash. Yeah. So that lesson one, yeah, enable Dependabot. Enable Dependabot, enable Dependabot, enable Dependabot. You can also come over here. You can set up a security policy and all sorts of stuff, but and code scanning, that's if you have like advanced security. What I like though Yeah. So here's a Dependabot. They'll like walk you through some of the things and Dependabot alerts. But you can go to settings, code security and analysis. You can turn on like the dependency graph so you can understand all your dependencies. You can like come in here and make rules and like enable or disable things. So I could like put everything into one pull request, configuration. That's going to take me right to this file. But again, they have right in the comment that link to all the configuration options. So, the repos, who's assigned, who's allowed to do stuff, like there's a bunch of configuration on Dependabot, but I think that this just helps keeps your workflows up to date. They change a lot. All right. So let's get to, I think I forgot one other thing. Yeah. So let's get to authentication and deploying to the cloud. So very easy to deploy to any cloud from GitHub. There's a ton of different vendors. I'm only going to talk about Azure. You want to use AWS, GCP, Oracle, be my guest. That's fine. But let's start with Azure. So pretty much with every Azure action or task, what you have to do before you can do the deploy, you have to authenticate. You have to authenticate in some way, and then you have to be authorized to make those changes. So if I come here to the Azure login action, and this is the one I'm going to use, we're on V2. So if I look, there's been a couple of different iterations, but we're on V2 right now. And they have a large number of samples of how to use the login. The one that's recommended at the top is OIDC. So who uses OIDC for any of their applications today? Who uses OIDC for any of your pipelines, wherever you're coming from? Yeah, so if you've ever, here I'm just gonna go to the action. I'm gonna scroll down to the action. The number one sample you're probably gonna see is something where it says like this: go get a creds, do an ADSP create for RBAC, and then take this credential block and stuff it in a secret. You're probably gonna see that more than anything else. They give you the command, and then they're like, just go log in with creds. This was how we logged in for years. This is what we did. You made a service principal, you had a secret, you put it in here and you logged in. That's great, but the problem with service principals, with secrets, even with certificates, if you have a secret or you have a certificate, and I get that, I can log into Azure with the name because I have the secret. I have the credential. There's something I can take or steal. When you go with workload federation, when you go with OIDC, yes, there's a client ID and a tenant ID and a subscription ID. There's no secret. So how does GitHub and Azure figure out who's trying to deploy? And this is where the OIDC implementation comes in. It works for all clouds that I know of that are big enough, I guess. Let me just, there's an image that I'm trying to find, hardened deployments. Should be right there. All right, so how does this work? So GitHub and a cloud have established some sort of trust together. So there's an OIDC trust in the cloud provider. So Azure, AWS, Google, Oracle, they're all going to say, there's an issuing authority at GitHub, and they're the ones who are going to give me some secrets. So they don't have to trust you or anybody. They trust GitHub, and there's a specific thing that they trust there. And so when your action is running, when your workflow is running, you remember I had provider or permission ID token right. The reason I did that was in my action, GitHub is actually updating the token, and it's going to send it off to Azure in my case. And it's going to say, hey, I'm coming from this repo. I'm coming from this org, from this repo, from this branch. Do you have a service principal that matches that guy or matches that repo? And if I've made a principal with the right federated credential, it'll come back and say, yes, this is who it is. That just authenticates me, or that just says I say I am who I am. It doesn't give me permission to do anything. I still have to go and do the next step of give that identity permission to make changes to my subscriptions. Let's take a look at what this looks like. So I'm gonna go ahead and log into Azure. Yep, okay. So I'm gonna go to Entra ID. Used to be Azure AD, so we're doing Entra ID. We're doing app registration. You see I have a bunch down here. So I'm just gonna go to GitHub Actions demo. Notice it says add a certificate or secret. It's because I don't have any. I don't have any secrets. But if I come over here to certificates and secrets, see 0 secrets, 0 certificates, but I have federated credentials. You can have multiple federations with one identity. So this one identity, I could say, hey, you're allowed to come from my .NET environment or my prod environment or whatever. Like I have that choice. So, you know, and I'll show you how to create one from scratch. But this is the scenario. It's GitHub Actions deploying. There is another one for Kubernetes. So if you've ever done AKS where you want like workload federation, you want like a pod running in Kubernetes, that would be issuing an OIDC credential. Same exact kind of idea, except this is GitHub. And so I've got my org, I've got my repo, and then I could say branch. So I could say, hey, if it comes from the main branch and it matches what I tell you, then it, you identified and authenticated this user. But then if someone made a fork or made a dev branch and they tried to deploy to the same identity, it wouldn't match. And it would get a rejection that nothing exists that matches that. So I can pick environments and I could type in stuff like .NET or prod or QA. I could do branch and I could do like, refs main or refs releases. I could do a pull request to say, hey, you're allowed to come in here if it's a pull request. You can deploy to my staging environment or my QA environment. Or I could even do tag. Like you have to have this given tag, maybe latest, maybe main, or release something. You're allowed to authenticate against this identity. So there's a lot of flexibility, but if you think about it, that's a ton of power too. Like you can be really, really granular based on that environment, based on that branch, which is why I have a couple in there because I'm doing this for demos. I would be more limited if I was doing this in production. All that does though is authenticate me. It doesn't give me any permission. I still have to do all of the normal things I would do in Azure to grant a service principal permission. I want you to be a contributor to this resource group. I want you to have permissions on the subscription. I want you to have permissions to here. So I have to grant that separately. Remember, it's who I am and what I can do. So back to our code. If we look at that one I just showed you about .NET, I have to give it the token permissions so that it can update the token. So when Azure comes back and says, here's who you are, here's your JWT token, it has to be able to write that to the session. And then here's my login. No secrets, no passwords. And I don't know if you remember when we ran it before, it actually showed you. So the first time you set this up, you're probably going to mess it up. I mess it up almost every single time, the first time I do it. But then you run it and you try to sign into Azure, and guess what? It tells you exactly what it's sending to Azure. There's my org, there's my repo, there's the environment I'm coming from. So it tells you the subject identity. So if you get it wrong and Azure comes back and says that identity doesn't match, yeah, we can fix it. It's not too bad. So if I come back over to, let's just do that. Let's just go ahead and do this. So it deployed successfully before. No, I'm going to change it. I'll just change it so it's easy. So I'm going to say this is actually I called the environment .NET 2. So it should not match. Now, see if that finishes. That finished. Okay. So I can just rerun this job. I don't even have to redeploy the whole thing. I can just rerun this one job. Nothing in the code base changed. Nothing in the pipeline changed. Nothing in the environments changed. The only thing that changes on the Azure side, right? This is why I like to do it. It's fun to play with code and just see what happens sometimes, you know? Now, the other thing is if you set up your OIDC correctly and you have the federated credential and everything, and you go to sign in, it can come back and say there are no subscriptions available. And it might say that if you didn't give it any permission to any subscription. Like if you haven't given any permission, it can't access anything. And it's telling you what you told it to tell you. So no matching federated identity record found. There's the identity it sent. I changed all the credentials on the Azure side. Here, make it a little bit bigger. So that it was .NET 2. So this is saying, hey, yeah, we can't log you in. Here's some documentation. You can try logging in. It's not working out. And the only reason was I had a different environment listed here. So I can change this back and I can rerun that same thing. And now that the identity has the right identifier and the right path, it'll work just fine. So rerun. I can even enable debug logging if I need to. That'll give me extra logging on that job. So we'll wait. We'll do the approval. So I don't like that a lot of times you have to, all of the documentation and all of the demos really kind of point you. Yeah, you can see it's doing all the logging, the debug logging, but it successfully signed in. And that was the subject claim. So successfully worked, no problems. So it was just that one little tweak to my federation. So we were talking about this guy, this login, and kind of all of the options and parameters. If you just go to here, how to do it, there is a create a service principal, assign a role. So give it permission, you're allowed to modify things, and then configure a federated credential. And there's that dialogue that we just saw of, hey, we added a federated credential, we plugged in our couple of values, and then we need to grab the app ID, the directory ID, and the subscription ID. So I don't like doing all this stuff manually. I find it annoying. So I put it into a script. There's actually a script in this repo that does all of that for you, because you can do it in the CLI. So like you can run something like AZ-AD app create to create an app registration if you wanted, and then you could pipe it into JQ and take the ID out and the app ID. And then if you had the app ID, you could then do AZ-AD app federated credential create. And you could pass in stuff like, you know, your org with your repo name, and if it was a pull request or an environment. So you can automate all of this stuff if you wanted to and have a very standardized naming and process. Here's where I assign the role to the app registration I created so it can log in. And then you can, if you have the GitHub CLI, you can actually set secrets as well on your repo. So you could just wire everything up consistently every time. So you don't have to use the portal for this stuff. You can do it all CLI if you want, or Terraform or something like that. So is this interesting? Is this something you guys are going to try doing the OIDC? It's much, much, much more secure. And this is the recommendation kind of from GitHub for how to log into every cloud. They go into the JOT token, they go into the claims that are all there, but under hardening, they have it for AWS, Azure, GCP, HashiCorp Vault. So I have some samples where I log into Terraform with OIDC. Other cloud providers. So it's not hard, but they will walk you through it. You just kind of have to see the dots kind of connecting, and hopefully it makes sense. Yeah, so for Terraform, let's see here. You can do the same thing pretty easily with Terraform. So I use OIDC for pretty much all of my logins. That includes Docker, Bicep, anything I can do OIDC for, I try to. Like so for Terraform, we can do interesting things like there's the permission ID token, right? I'm doing the OIDC login, so the login with the client and the tenant. This creates like a storage account. But then we can just do the init and pass in the backend stuff. It's already logged in. So it takes the OIDC secrets and uses them for Terraform. So you don't have to do a lot of crazy stuff to get Terraform to work with OIDC. All right, let's see a couple more topics to hit. Who likes semantic versioning? You guys like semantic versioning? So there's a really nice extension I came across recently talking about semantic versioning. Where was it? There we go. So semantic versioning. So this workflow, I started from scratch and was playing around with it. I found a really nice action from Paul Hatch. So I want content right as a permission. So I mentioned you can do different things with checkout. So if you're ever dealing with tags in Git branches, you want to do a checkout with a fetch 0. The Git checkout can also automatically handle submodules for you. So if you're using submodules, there's an option here like submodule yes, and it'll just automatically get all your submodules for you. So you don't need to do multiple command line steps with Git module update and all that. Like this will handle it for you. But what's cool about this is it will pick up from where it left off. Like it'll search your tags, it'll search your branches. It can automatically like specify the version you want. It'll bump like your patch version by individual commits. And then I add them, I take the outputs of the version and I add them into a variable. And then you can tag the branches like automatically based on individual commit versions if that's what you wanted to do. So if I look at this guy, you see I have 7 tags. If I look at them, V101 is the last. So if I come in here and just edit this guy, test, and commit that, this makes my life a lot easier when I'm dealing with tagging. Give it a sec, should kick off. There it is. So if we look at this guy, well, it's already done. So the checkout, because we said fetched up 0, it's going to get all the information about the tags. This runs and has figured out version is 102. And then it even gives you a little link to make a release. I printed out like some of the environment variables just to show that I added them, but we created a tag and pushed it. Now, one cool thing about this tag, this is what this action, this is what I like. It's pretty cool. It responds to code commit notes. So like if I say in my commit message, like, hey, this is a major change, it can do a major or minor bump. So if I do something like minor, this should bump it to 1.1.0. So it's a nice little action that very quickly can help you build up some nice versioning. Yep, 1.1. Who has scripts to help you do the semantic kernel version or semantic versioning? Yeah, is that a little bit easier? Git version does too, yeah. But it's nice having an action that can do it. I have a lot of fun. I was just playing with these different ones. It's a nice action. It does exactly what it says it's going to do, and then you can fully customize like the little tags here at the front. You can fully customize them through this configuration if you want it to do certain things or not want it to do certain things. So I just find it nice. I hate maintaining all sorts of little silly scripts all over the place. Yeah.
May I ask a question?
Yeah.
We go back looking at this and going back to your discussion a while back around security.
Yeah.
And tagging.
Yep.
So one of the major issues
Yep.
I've always had with GitHub is this.
Yep.
XC.
Yeah. So there's let's see here.
Security reviews and security departments hate GitHub actions.
I'm sure you do. Yeah. There's actually a nice document out on Azure that I like about tagging and versioning of containers and like when to use stable tags, like V1, V2, specifically talking about like base images, like base images where the image can update versus like unique tags where you're using that commit or datetime tag. So like this is a nice discussion of it, and there is, but yeah, I understand security implications. Always fun. Yeah. All right. What else I want to hit? Yeah, we'll go in here. So another use case I see a lot of times is UI testing. Who does Selenium or Playwright or some sort of automated UI testing? Only a couple of hands. Okay. Well, you might find this interesting, you might not. There is a thing called Playwright that is a nice open source tool. Playwright is actually like an npm package. So you do like an npm install Playwright. Well, on GitHub, you can say, hey, go install the dependencies. Those are like the little browser pieces like Firefox and Chrome/Edge and WebKit. So you can actually unit test with Safari, essentially. So we can run our tests and generate a report right inside GitHub Actions and have it like attached to your PR. So, or you can take like your HTML out and store it in a storage account for review. So just like everything else, if you can do it on the command line on your own machine, you can really automate this through actions. So these are all very easy steps to do. And for Playwright, like they actually have a nice piece of documentation right on their site around how to do GitHub Actions. So if you're like using something like this, they actually give you the workflow file. Like, so you don't have to figure it out. They're like, here's how to implement Playwright on GitHub Actions. And you're gonna find this with a lot of third-party tools. So Sonar, Cube, they're gonna have, here's how to implement it into your GitHub Actions. Veracode, check marks, if you're doing security scanning, a lot of them have how to do it. If you're using something like a Trivy, all of those show you how to integrate into their GitHub Actions. All right, what was the thing I was gonna show you next? I remember now. Getting old, I'm forgetting my demo orders in some cases. All good. So there's a couple we didn't hit earlier that I want to circle back to because I think these things are really nice. So I mentioned we have some really cool things we can do with PRs. One of them is, what if we have that concurrency where we're like, hey, if we have 2 or 3 jobs with the same number, we only want one to roll. What if we, on PR, we made a resource group? Like, you know, if it's PR5, we make resource group 5. And we just go out and deploy our code for you to review and look at. And then when you're done with your PR and you close it, it just cleans everything up and it goes away. So because we can do stuff like on pull request, and we can do other things like on PR closed, where we can be like, hey, it was the closed version. Go ahead and just delete that resource group. We can actually do some really cool stuff. And you can use these ideas to build. So let's just make a pull request of some kind. Let's come in here and edit this file. Here, I'm gonna change this to toy play site. I'm gonna edit this. I would normally have PRs in place. I would restrict the environment, all that fun stuff. But what I'm gonna do here is we're gonna make a branch. And we are going to make a PR. So I've opened a PR. So now, if I look at my actions, well, I have a ton because I just have some with pushes, but you can see PR validation is running. This is going to lint my code. So another cool thing that we haven't really gotten into yet, templates. Templates and reusable workflows. So this says it was linting my code. And here, my lint step uses workflow lint. So I have a lint file in this repo. Now you can reference workflows from other repos. There's all sorts of different capabilities you have. Here's our lint workflow. Notice the trigger, workflow call. So this only gets triggered when somebody calls it. Doesn't get triggered on push, doesn't get triggered on manual, like something has to call it. And this is just doing a bicep build. It's just doing something basic, but it could be something much more complex. This could be your build task and you're passing it the CS_proj file. It could be an archive and it's go deploy to an environment. So you can pass inputs into your workflow calls. So on the calling side, you would say with and have the variables that you want to pass it. And here they would be inputs. We'll take a look at that a little bit more in a second. So let's just see if this job ran. So this is still going. The lint finished, it's still doing the deploy. And if I look out in Azure, again, let me close some of these guys. And if I look at resource groups, PR35. So this is being deployed as we speak. So this was created just for this deployment. Looks like it just finished. So if I go back, yep, it's all done. I would check out my website. It does tell me on my summary. If I look at that deploy, show website hostname. Go check it out here. I can go look at it. I assume everything is great. I have a great time looking at my website. I approve it. I think it's awesome. That was an amazing change. I put a space or something in there. Couldn't be better. So I'm going to merge this pull request. Because I too like to live dangerously. And then if we look, of course, all the other things are triggering because I have so many demos. But PR closed. So this is out removing that resource group and cleaning it up. So this should go away now. So Azure DevOps doesn't have the PR closed capability. You have to do some other things to make it work more effectively with conditionals, but like that is a nice little convenience thing. It's also a security thing I get if you want to do, depending upon what you do. But yeah, this is one way you can clean things up automatically. Yeah. All right, so I did mention linting. One thing that they put out, another thing GitHub puts out, is there's a thing called the super linter. They actually give you a workflow file for it. Who lints their code or uses Sonar or something? Nice. So super linter, they moved to here. Super linter, it has a few things. It will lint a lot of little things. It'll find copy and paste detection. It'll lint your HTML, your JavaScript, infrastructure as code using Chekhov, does markdown lint, has a lot of different options. So you can actually go through and turn on and off individual linters, or you can just include the super linter and it'll like pretty much find everything it can. But one thing I did was I went through and I customized the number of the linters. So this will tell you the default variables and locations for all these things. In my repo, I put all of the stuff inside here. GitHub Actions, linters, here's my configurations. So like the copy and paste detection, I tweaked the throughput because I had a lot of demos. They're like, hey, these are all copied and pasted a lot. I'm like, stop it. I don't care. Markdown lint, you can tweak your rules. So this is a really nice way to have a little bit of consistency across your repo by turning this on. It can, when you first turn it on, if you're not careful, get a lot of noise over the signal, but it's a nice tool if you're looking for something to help with a lot of different languages and topics. And Chekhov is always good. I'm a big fan of it. All right, what else? Yeah, so let's work on reusable workflows a little bit. I'll let you guys, let me close that. Because we can play with the reusable workflows a little bit. Those are extremely valuable. So there's a couple of ways. Let's see, where was it? Creating it. So like I said, the creating it, you really just need the workflow call, but we can do some paths and inputs and secrets injected into them. So if you know, like, I'm building .NET, I'm building a container, and I want a certain tag passed to it. I need to use this Docker file and go build it in this folder. Go do this thing. You can define those inputs very clearly on your call. And then, just like with everything else where we're passing a with, we just use this action past these things. So we can do that same type of behavior on the job. Call this thing using this workflow, and here's my secrets. The reuse is really, really nice. So they have a skill demo out there that we can work through together if you guys would like on reusable workflows. So this little sample, you guys can do it yourself, but this little sample will take a workflow and kind of use it in a matrix to show like, hey, here's an easier way to build and do all these things. There's a lot of really cool capabilities with it, but let's see here. Steps. There, reusable workflow. Yeah. So required type string. And then, yeah, so pulling this out and putting in that in a matrix. All right, we got about 30 minutes. I've been doing a lot of talking. We've done some demos. What about questions? What questions you guys have? Or specific topics you want to circle back on that I haven't addressed well? Or things that you want a little bit more clarity on? Come on. Yeah.
So I know that this may not be applicable, but I was just wondering, are you able to see like exact API calls or like CLI calls in some of these actions that are like, one that comes to mind is Azure deployment one?
Okay, the Azure deployment one?
Yeah.
Yeah. So remember what I said about if it's an action in the marketplace.
Yep. Yeah. So
It helps if I spell it. So Azure, it should be, like, let's say web app. Yeah. So I can go over to the repo. And what you're going to see is there's a lot of tests and libraries, but see deployment provider, utilities, like the source code's there. That doesn't mean that you know exactly what's happening, But like this is validating the input types, and at some point you're going to see some sort of call. So kudu service deploy using this. So I could go into there and go find, go look for deploy using that and see where it is in here. Like it would be somewhere in the source code or in one of the libraries. But yeah, so from core, so it's probably in here somewhere. So Azure Actions, REST Service Utilities, something like that. But I just don't know enough about this specific code base.
Also, the output mostly comes from the creator of the extension.
Yeah, so
If I don't
yeah, here we go.
add any right outputs, it will not tell you anything.
Yeah, so here you can see it's getting like published profiles, it's pulling secrets and get published profile. So there's some stuff happening with the REST calls to make those things happen. But it's all going through this kudu service. So I would go track down like what's happening in the kudu thing, so find this.
No, I understand the general workflow now.
Yeah, they're all open source. So if they're in the marketplace, you can go figure out exactly what's happening. And you can turn on that debug as well. So I turned on debug for one of the runs, and if you look at that depth of documentation, or like output, there's a ton there. Whether you can, figure out what you need or not. Let's see here. Yeah, see, so that was downloading the artifact. It's a lot of debug statements. So deploy. So it's checking the formats. It's running, some validation that creates a deployment. AZ, deployment group, create, resource group. Like you can see the commands it's passing to the AZ CLI.
Yeah.
So it all depends on how much you want to dig. But all the stuff's there. It's pretty open. Just confusing maybe.
Yeah, exactly. You didn't know where to start with that, so I appreciate it.
Yeah. And yeah, if you guys aren't, definitely get to a point where you're trying this GitHub Actions. It is very nice. So, I can see all of my workflows. I can see the different jobs as they run. Like I can right click and rerun it. I can click on the little world and it'll take me right to it in the browser. So that's for the current branch. I can see all of the workflows, and then for a workflow, I can dig into the history of that and see the individual runs of it. And trigger it, open it right from here. Don't even need to go to the browser. And then the secret and environment management. So, now that we've talked about environments, I can come here, and while I'm iterating, I can tweak these things. I can tweak the variables, tweak the secrets. This is this is really nice in a workflow. Like when I'm working on stuff, syntax highlighting, it will do some completion for me. I think, yeah, there was one that was like showing me versions, but you notice the squiggles. So like it's giving me a squiggle here because unable to resolve that action. So it will do detection of the version. So if I did version 3, it's okay with that. It found that version. But if I do 5, because that doesn't exist, can't find it. So this is a nice thing. Another really cool capability is Copilot works well with this. But I did mention Actions Importer. That if you guys were looking at moving into GitHub, they have this. This is a tool that they put out, the GitHub Actions Importer. This will run from DevOps, Bamboo, Bitbucket, GitLab, Circle, Jenkins, and help you automate your migration to GitHub. Like it tries to find the matching extension in GitHub that does the similar activity and helps write out the workflow in a very similar way. Yeah, so here's demos of it from different environments. So I know somebody said Jenkins earlier. Ooh, that's a lot of secrets. Yeah, see, it finds all the actions and is like, hey, I think this is a matching action, this is a matching action. You have to do some tweaks, but it does let you import and will write out this stuff. There we go. So cool tool if you're interested in those. What else? What else?
Would you say that GitHub Actions is more like feature rich than DevOps pipelines? If you're gonna switch from like Jenkins to one or the other?
There's so Peter DeTinder did a talk earlier today about Azure DevOps and GitHub. They both have their strengths. So if you're just looking at pipelines and stuff, I think GitHub Actions does have more power now than pipelines. But like if you're doing agile processes, Azure boards are just better, just hands down for agile and Scrum processes. Like if you just want to light, hey, I made an action, I closed it, or an issue and I closed it, GitHub boards and projects work fine. I think a lot of enterprises like the boards aspect. If you're doing manual testing, there's not an equivalent on GitHub. A lot of times people use tags or labels on PRs to move things around environments. There's a richer approval flow and trigger flow on the Azure DevOps side. That being said, like GitHub Advanced Security, super powerful SaaS tool. They have recently ported it to GitHub or to Azure DevOps. So there's GitHub Advanced Security for Azure DevOps. So they did port it over there, but I mean, there's still a ton of stuff on the Azure DevOps roadmap. Like it's not going anywhere, but there's a lot of cool features that come to GitHub first. The most notable is like 4 days ago, they have VNet integration for GitHub runners. So what that means is if you have a solution in Azure that's fully private, you have hub and spoke, no external access, you're just doing stuff internally. Today, if you're in that scenario and you're trying to do Azure DevOps, you have to spin up a VM in your private VNets and then use your own self-hosted runner on that VM because you can't approve from the big pool of Azure hosts what can get into your network. It's not good. It's not secure. And so you run your own runner inside your own VNet, and it's a pain because now you're maintaining an image and all of that. The other option now is GitHub has private VNet injection. So you can actually register one or two of your runners to be able to access your private networks. Like you give it an IP, and that's what the runner uses to communicate and deploy to your software. So Actions can do that. It's GitHub Actions private VNet. It's like like 4 days old. Private networking. Yeah, WireGuard. Where was it? They had an image too. So private networking for GitHub in your organization. There it is. So you have your workflow, triggers your runner. It makes a runner, which deploys a NIC into your network if you've configured that. That way, it picks up the job and it can deploy into your environment. So this is very new. So, yeah, but yeah, DevOps doesn't have Dependabot right now. They both have something called Defender for DevOps, which will scan your code bases. Another thing that adds, I think, push protection on the Azure DevOps side, but push protection is something that's in GitHub, secret scanning and push protection. Have you heard of those? Do you know what that is? Okay, so secret scanning will scan like GUIDs and passwords and secrets, all sorts of stuff. And when you try to push a secret to a repo, it can detect it. Now, push protection takes it a step further, and it registers itself with like the Git remote write, like one of the hooks in Git for when you're pushing code, and it'll actually scan before it saves it on the push. And if it finds a secret in there, it can block the push. So even like in your local repo, if you've checked in a secret or a key and you can commit it locally, and that's fine because it's on your machine. I mean, it's not fine, but when you push it up to GitHub, that's where it stops you. So it's really neat. But they have this huge list of secrets that they support scanning for. So if you try checking something in that's bad, they'd let you know. In some cases, they can work with the cloud provider or the software provider and disable the key immediately. In other cases, they just let you know. That way they don't kill your software because your key stopped working. I think it varies. But yeah. Those are neat. Yeah.
Just reading things like reusable workflows,
Mhm.
shared actions. The way I've done it in the past, I'm using just like an actions repo. Is that still kind of the best way of doing it?
I do that a lot. I have like a workflow repo or an actions repo, and I have in there like, here's how I build .NET, here's how I build Docker, here's how I build this, and I parameterize them, because if all of your other workflows are using, here's how I build this and here's how I do that, it's very easy for you to implement security and scanning in one spot. If you change your SAST tool in one spot, you change it, and all of the workflows now can leverage that new capability. If you add in a linter, everybody gets the linter. If you enforce code coverage or tests, like, yeah. So that's typically what I do. Yeah, like I said, there's also this Learn module out on Microsoft Learn. So if you can come out here and you can search for stuff like GitHub, and they have a large number of modules here as well. But then you can come down and say, hey, I want a learning path. So there's a bunch of different learning paths on like Copilot or administration or projects, but the one that I think is one of the best ones is automate your workflow with GitHub Actions. So this one is also, it does stuff here and it does stuff on GitHub using some of the skills things. But what's nice is, where was it? Like they even go into like using the GitHub script and the SDK. Like, and you know, there's some, like this one has building packages to the container registry. You know, and so they'll walk through like, hey, I'm going to use this setup node using this registry. I'm going to publish it to container registry. Like they walk you through these. So these are nice little bite-sized chunks of information that you can do on your own. Just like with, yeah, and this one, I start it, it takes me over here to the skill stuff. So they're all very integrated in what you can do. Yeah, publishing, this one is super easy, just like with the other ones where we're like publishing, where was it, step. Yeah, like build push. That's really all it is. Like you're logging into Docker registry, but pointing at the GitHub repo, and then you're just doing a Docker push. There's just so many different actions out there. It's how you put them together. There's some more complex ones. There's less complex ones. I usually separate my build and my release. I have my test in with my build stuff because I want fast feedback. I might deploy it out to a dev environment to do acceptance tests. You know, like how you split these up. It's okay having a lot of little jobs instead of having one build, you know, one huge job. So, good question. What else? All right. Come on, guys, you've been kind of quiet. I'm trying to cover a lot, but I don't want to just be, I want to make sure that you guys get your questions answered if that's what you want. Let's see, one of another one.
Give me examples for only triggering like a run or an action
Mhm.
if certain files change?
Yeah, that actually, okay, I don't think I have one written out, but on events on GitHub, they actually have one in there. So for file, or was it filter? So if you do branches and path, it will only trigger if both are met. But like, you can have it list a single file, or you can use the star syntax. The star syntax will find it like anywhere in the repo. So if any JS file gets changed, this will run. So I could change it to be like, my web.config or something like that. I could have it just be one specific file. Yeah. What's your use case for that, if you don't mind?
On one of ours, it was exactly what it was, but it was we only wanted to trigger tester test on if certain files change.
Mm-hmm. Yep, and you can. I think there's some scripts that you can do. Let's see here. There's something I saw. I'm trying to remember. Change file. I know there's some actions out there that do this. That do like the difference between the last commit and this commit, and then it will like give you a list of the files that have changed, and then you can figure out what you want to do with those. Like, but you could just do the filter where it's like ** PowerShell, or here's the path to the PowerShell folder.
That's how I've used it in the past. The thing mentioned, getting a GIF file.
That's what this does, and then it says only get the ones that are changed with change that have that extension, and then it gives you back that array. Yeah. Yeah, but there's a ton of actions out there. Again, look at the stars, go look at the source code, check it out. Like, just because there's an action out there doesn't mean to blindly use it. XV. Huh? Yes. Get diff, yeah. Sometimes everything's a nail when you have a hammer. Come on. But so if we hit all the use cases you guys were thinking about building software for or using software for.
Yes. Okay. I'm still curious. I asked you to show YAML template again.
Oh, I'm sorry. I thought I did.
No, but you did. So one thing I've been working with this, and I've even created my.
Yeah, your own actions and stuff. Yeah.
One of the issues I found in the documentation is those bracket GitHub .events .
Yeah.
Something.
Yeah. Okay.
Just so and so documented what they contain, what they actually. Yeah.
Yeah, it is. This does tell you, hey, this is a string, blah. Like they tell you some stuff. The thing with events is this contains, like if it's a push event, it contains, so you have to go and look at the events. And then.
This is why I wanted to see that again. Can you do this by GitHub.events and just convert this to a JSON, spit it out for me so I don't have to read a billion lines of bad documents? Sorry.
Yeah, the reason I skimmed over the GitHub to JSON is it has email addresses and hashes, and so I was just like, I'll leave this as an exercise for you in your own repo, especially considering everything's being recorded. So that's why I was quick over that, and yeah. But it's two pieces. So yes, this event is here, but then this event is very specific to what your trigger was. So for push, it does tell you, like, here's the webhook event. Yeah, there's the payload. So let me go back up to push. So here is the push payload, event payload. So this is telling you all of the things that are in GitHub event when it was a push. So it's going to give you a ref like before and after, when it was created, the enterprise, the head commit. Like, so this stuff is documented. That's all like different events and payloads. So you don't have to go to JSON it. You can come here and see what the properties are. And oh, here's all of the properties. Oh, and here's all of the properties of this. And oh, here's all the properties of that. So, good? All right. So we talked a little bit about building Docker and stuff. We talked about triggering. What else? What are things that you guys are doing that maybe we want to touch on a little bit more?
So at our company, we do build once, deploy many.
Yep. Okay.
Is there a way within GitHub itself for us to go ahead and store those builds rather than us throwing it out to like?
Yep. That's GitHub packages. So, yeah, GitHub. And actually, some of those skills deal with that. Some of the little workshop things deal with that. I didn't really dive too much into it because I figured I wanted you guys to be able to play with some of that more at home. I wanted to make better use of your time. But let's say you want to publish something to packages. You can do all sorts of access. You can do releases. But if I want to publish one, I give it packages write permission. You can log into Docker, if you want, and then just push it up there. So that's one way to push stuff. They have samples in the new workflow. So like if you say new workflow for your repo, I think it even signs the Docker images by default. This publish step, like this will walk you all through it. And that's another skill where you're going to be publishing packages, because GitHub does have on that side here also the releases. So when you're signed in, it'll say like, I want to make a new release as well. So if you're distributing it out to places, you can make releases based on your tag. And you can do that. You can do packages. You can do artifacts. So a lot of times what I do is I don't even do the packages to publish. You'll notice in the .NET application, I didn't publish it out to packages or anything. All I do is upload an artifact from my run, and then later on in the run, I download it again. So there's some like internal storage you get for passing between jobs. So upload an artifact for deployment. Go upload my web app. So I compile a web app and I'm just uploading it as an artifact on the run. And so if I need to roll back, that will still be there for whatever my retention policy is. So a lot of times I would be like deploy to dev, and then I can copy this and deploy again to prod. And maybe here where I'm passing in some parameters, I would pass in different parameters based on the environment. That way I'm taking the build and just pushing it with overriding the configuration. They have some for managing YAML and Helm charts. They have some for managing. So if you're doing a GitOps thing, if you're transforming, YAML, if you're doing the transform on deploy, a lot of those tasks have that capability. So, I was using web apps deploy. So if I go look at the web apps deploy task and we look at the documentation, like there's a publish profile for that one, configure credentials. There's one for like setting up services, so you can override it per environment. So there's different, like it varies based on application. So for Java, you do it one way. For .NET, you do it a different way. If you're doing the deploy actions, you do it that way. Yeah. So, but yeah, I usually just stick with the hey, I upload it up there and I download it down here and have multiple tasks.
Can I see that upload portion again?
Yeah, so this is the actions upload artifact.
So would that be underneath like that releases page that we saw on the GitHub?
That's a different thing. Like for this, I don't. So if I go to my, and I'm sorry if I confused you. So let me go to the run.
No, you're good.
So like here's a run I did earlier. And so if I look at build, well, let me go back. You see there's two artifacts right here. So I can come here and I could download. See, there's my two artifacts. They're right there. And so they exist in our version to kind of for this run. So the if I made a code change, I could go download a different artifact. Like the next run would have a slightly different artifact there. So I can just come back here and like redeploy this guy and it would redeploy that existing package without having to rebuild it or get it or anything. Yeah. So lots of searching for things. There you go. So this is the upload artifact. And this is by GitHub, like this is one of their core ones. So they have the like what changed, inputs, upload a file, a wildcard, environment variables, expansion, like and then the limitations and like how long, where does it go? Right there. All right, what else? Got about 10 minutes left. Okay, come on. Are you guys using code spaces at all? You guys played with them? Do you know what they're about?
We just talked about them, but we're not using them.
So I put stuff, I put dev containers in most of my repos now. And I actually you can put multiple. So like for my GitHub Actions one, it spins up a base Debian that has the CLIs and Docker and .NET and Act. And then I can actually say, go install these GitHub extensions. Like you can pretty much build your image. But if I want to use this locally in Visual Studio, I have to have Docker installed because it's running in a Docker image. What's really nice about code spaces is I can use that exact same configuration file and I can come here and spin up a container image, that matches my definition. I can connect it to my local VS Code. If somebody wants to come and work on the project, they get the same settings, the same extensions, the same versions. Like who's ever had a problem with somebody on the team using the wrong version of .NET or Node or Python or something, and then they check it in and everything breaks? Yeah, I'll do that later. So for Python, for instance, the people that write the core engine of Python, CPython, look at that. They get a dev container. So they use a Docker file that they have set up, but then they're like, hey, we're using these extensions when you work in CPython. Here's the settings. Because we know the image, we know exactly what the path is to CLang. We know the flags we're going to use. We have the editor rules for spacing and indentation. Like, it's very explicit. You guys do home automation? Anyone know about Home Assistant? They use dev containers and code spaces as well because there's a .dev container. They also use GitHub to build stuff. So they use a .docker dev. You can have hooks to run stuff on startup and shutdown. So yeah, you can do port mapping. You can do environment variables, like I said, extensions, settings, customizations. It's a really cool thing. It really helps onboard people and have consistency very quickly. So if you aren't using them, look into them. They're really cool. Yeah, that's, so this is running in a dev container. See right here? I'm the act. I'm even doing Docker inside Docker. So I'm doing act using Docker inside a Docker container. But most of the time when I am doing something and I have a containerizing.NET talk. So if I open it up, so this is just running it in WSL. So it's not running in the dev container right now, but I can reopen a dev container and it'll go and rebuild my image if I need to. I can see it's setting up my dev container. So it's building all this stuff. What's cool about CodeSpace, it's asking which one I want, so I'll just do my slides one. But what's cool about dev containers in GitHub CodeSpaces, you can have it open in your browser, or you can have it open in your local VS Code. So it'll just do a network connection back up to the cloud. It's an easy setting to miss, but it's just cool stuff. I really like it. You under your settings, there is a CodeSpaces option. So you can tell it to use dot files, so it has your consistent stuff. You can have special secrets for CodeSpaces. You can have trusted or non-trusted repos. You can, say I want to use Visual Studio Code on the web or JetBrains. Turn it off, delete it, all sorts of different capabilities. And if you don't want to set up one of those files, you can just come here and say create one, and they'll use the default GitHub image, which has every tool just on the runners, already built and set up for you. So you can have a 32 core machine with all sorts of memory and run it like this. So yeah. Anyways, that's bonus stuff, but I like it because you can actually use your dev container that you built for development and use that to do your build as well. So you have more consistency as well. But I think that's everything. Since nobody else has questions, unless you guys have another question, go use Docs GitHub. You saw how much I was using it. It was pretty easy to find the thing we were looking for. Sometimes it's not knowing the right word, but it's there and it works and it's very good. The DevOps documentation is great. The GitHub documentation is great. They both are really good. Skills, go play around with those. They run you through different scenarios. You can go and kind of explore and then fork the repo. All these actions demos, they're all here. You can go look through. Everything's open. The slides are all there. The learn paths are up there. And just pick a repo that you have that you don't have an action and go make a new action. Go make a new workflow. So I'm in .NET, and what do I want to publish, or do I want to do it, Docker? And I can configure it, and I can take a look at it and see what they're doing. So, all right, that's just doing a Docker build. Well, and it's giving me a tag. What about this one? This says build, test, and publish. So I can come over here. It's using the GitHub IO registry. So it's got some packages, right? So there's the packages. It's doing cosine and buildx. Notice these are using the full hash. Gotta keep our friend happy. If you have a registry, it will log into that registry, extract some metadata to pull out the tag name and stuff, and push. And then sign the publish build. So just by exploring what's already there, now we see steps meta. So I can come back up here and I can go look, and there's that meta one and the ID. So remember, if we want to use the outputs, we have to give it an ID. We can see this in the samples. Stop build and push outputs for the digest. Well, let's go find that. There's build and push. So all comes together. And there's a ton of these. So like another fun thing you can do, like there's code search. So cs.github.com. This is a really cool search engine for GitHub. You pretty much look whatever you want. .github workflows. Do you guys do this? Because I do this all the time. If I'm trying to figure out how to do something and I know a file exists, like it's something in the .github workflows folder, I will look for .github workflows. And then, what do I want? I want Docker. How did they do that? So I can look at the repos, see the repos on what they're doing, and then, like dig into their implementation and try to figure it out. Like, everything's open. Use it. Like, if you're trying to figure something out and it's not clicking in your head, go find one that somebody did, So that's my suggestion. It's really, you'll find some really interesting use cases. So there you go. If workflow run a success on a pull request, then go run some script to update the owner or add comments. Like, you can do some interesting things, like create issues automatically and assign them to people. Like, tons of flexibility. Download the artifacts. Yeah, so poke around, explore, try making some actions for your stuff, okay? And that's it, guys. I hope this was beneficial for you. I hope it was helpful. So thank you, guys.